everybody, this is Miss Peachy from your WCA Astronomy A class, and today I am going to be doing a little tutorial for you on your portfolio for Unit 5, Lesson 8 and 9. So basically what I've done is I've actually dropped again the portfolio that is in the lesson. Again, it would ask you to go outside and actually make observations of the sun and make observations of the moon over a 3-day period. And while I think that's a very worthwhile activity to do, it's also asking you to submit the portfolio on the same day it is assigned, which really doesn't make a lot of sense when it's asking you to do it over 3 days. And with the weather being what it is here in Wisconsin, sometimes it's cloudy and it's difficult to do that kind of stuff. So I have substituted an activity where you will actually be doing a simulated observation, kind of similar to what you did in the previous lesson, but with a different website, and hopefully it goes a little bit smoothly for you. So let me explain what you need to do. First of all, let me bring up, see if I can get it up here. Hang on one second. As always, I have so many things. There we go. So I bring up this Google Doc, which is what I have made for you. So you'll be using this and then making a copy of it and submitting this into the Dropbox for your assessment for this portfolio. So again, as always, you can't edit this particular doc. You have to make a copy of it or download it to be able to access that ability. And you're going to go to File and make a copy, and you can edit the copy, or you can go to File and download it as a Word document, make your changes, save it, and then submit that to the Dropbox. If you're using it as a Google Doc, that is fine, but then when you download it, just save it as a Word document and put that in the Dropbox so that you can Dropbox an item. Otherwise, you can't Dropbox a Google Doc. So the first thing you're going to do is you're going to go to this website, gps-coordinates.org, and you are going to find out what your longitude and latitude is. So I've already done this. It does ask for your location. If you hit yes to share your location, then it will automatically tell you your latitude and longitude. Otherwise, you can put your address. If you don't feel comfortable putting your own address, you can just pick something nearby and choose that as an address. And it will give you your latitude and longitude. Pay attention to the fact that our latitude and longitude, it's given in here either north and west here, which is what you're probably familiar with, or we're going to use it in decimal degrees because it's what the computer recognizes. So I'm just going to round to the nearest whole number. My latitude is 44 degrees latitude and negative 88 degrees longitude. Okay, 44 degrees latitude, negative 88 degrees longitude. So I'm going to go ahead and write that down on this document here. 44, negative 88. That's my latitude and longitude. I'm not going to actually write this down because, well, let's go ahead and do the copy. That'll be easier. I'll make a copy. That way I can write that information down and not forget it, because sometimes I don't remember things very well. So 44 for longitude is negative 88. Oops, it should be on here. Okay, there we go. So then we're going to go to this separate site, the Earth Space Lab site, which I also have opened in one of the windows. Here we go. Bring that over here. When you open this, it's automatically going to be running to start with. So I want you to go ahead and uncheck rotation of the Earth right away. I don't know why it's being... Let's try to reload that again. Okay, I'm going to go ahead and uncheck it. Okay, for whatever reason, it's misbehaving at this time. You just want it to stop rotating. It should, in theory, now not be rotating and now be rotating, but for some reason it's misbehaving. So do whatever you need to do to get it to stop rotating, if this is checked or unchecked at the time that you observe it. I'm going to go ahead and change this to 44, down here to -88. That's where I'm going to be. Now to check if I'm in the right space, I'm going to look and see, does this show up? Here, I have to hit enter. Does this show up? And it does show up that I am in North America. Now it's hard to see because it's dark there, but if I let it rotate for just a little bit longer, you'll see that I am in the right location. Okay. So we're going to change the time here, and we're going to select a different season. So going back to the document that I shared with you before, the first thing you're going to do is you're going to determine the direction of sunrise, the direction of sunset, the max altitude, and describe the orbit for each of the 4 seasons. Now, I'm going to start off by helping you out a little bit with spring. I'm not going to give you all the answers here, but we're going to help you out. And then you're going to be doing summer, fall, and winter on your own. Okay? So let's go to spring. Spring is middle of March, March 22nd-ish, right? Can't change the actual date here, but we can change the month. So we're just going to move this course of the year to March. So what I want you to do is you're going to be observing the direction of sunrise and sunset. So I'm going to click and drag the celestial sphere here so that I can view where does this yellow line start and begin on the compass. It's easier to see that if we can kind of look almost straight down at our person. Okay? Almost straight down at our person. So I'm going to go ahead and just click off the rotation of the Earth here to observe the sun. And there's your sunset. And it should come back. And it's rising right there. And it will be setting right there. So essentially what we want to do is pick the closest compass direction, either north, south, east, or west. And obviously we know that the sun rises in the east and sets in the west. So when you're looking at rising and setting position, don't just put east or west. Is it east? Is it closer to northeast, which would be right in the middle? Or is it closer to southeast, which would be right in the middle here? For setting, is it due west, or is it closer to northwest or closer to southwest? So your option should be east, northeast, or southeast, or west, northwest, or southwest for the positions of rising and setting. And that's what you're going to write here. Which direction did it rise? Which direction did it set? Okay. Then for max altitude. Now I'm going to click and drag this so that I'm viewing it from the side like this. So what I want to be able to see is how high in the sky did the sun get in the course of a day. Now, it's a little bit difficult to see here because, let me see if I can zoom on this. I don't know if I can. Yeah, I'm actually going to zoom out. I'm just zooming out a little bit here, putting my zoom at like a little bit further out just so that I have more room to see. But what I want you to notice is that the horizon represents 0 degrees altitude. So when the sun is setting, it is at 0 degrees. When it is rising, it is at 0 degrees. As it moves through the course of its day, it goes higher and higher in the sky. If it were to get way up here, where the cursor is, that would be 90 degrees. It does not reach 90 degrees right now, okay? If it were halfway between the ground and the top, right in the middle, That is 45 degrees. Okay, that is 45. So halfway in the middle is 45, all the way is 90. It is kind of between 45 and 90, but it is closer to 90. So we have to kind of estimate a little bit here because we can't really see all of the degrees on here. They are on this globe, on the celestial sphere, but it is kind of difficult to see that. Um, so yeah. So my estimation with this yellow line, the top of it where it goes, is this 45, that's 90. I mean, it's really close. I'm going to go with around 80 degrees there. That's an estimation for me, around 80 degrees. Okay, so that's what you're going to be estimating. How high up is the maximum position of the sun? So I'm going to give you that answer. Oops. Hang on. I'm going to give you that answer. I hit the wrong button for this one. But I want you to be able to do that for summer, fall, and winter. And then finally, the orbit description. This is another one that I'm going to help you out with for this one, but then I want you to do them on your own for summer, fall, and winter. This time we're going to be looking at this window. And what I want you to see is, I'm going to click and drag this. And I want you to notice, as I do this, is the sun, or sorry, is the earth compared to the sun, is it tilted towards the sun, tilted away from the sun, or straight up and down with respect to the sun? So look at the axis of the earth. Is it tilted towards the sun, tilted away from the sun, or straight up and down? And I would say the axis is straight up and down right now. Okay? So that's what we're going to record here. Okay. So again, now you just need to complete the remainder of this data table. Finish what we looked at for the sunrise direction for spring, and then do all of it for summer, fall, and winter. And that is all you need to do for this portfolio. Go ahead and save this and submit it to the Dropbox when you are finished. If you have any questions, let me know. Otherwise, good luck to you and have a great rest of your day.